Dear students, welcome to our science episodes. Today we are going to discuss motion. Motion is the change in position of an object over time relative to a reference point. The object is said to be at rest, motionless, if the position of the body is not changing with respect to the reference point. So, in this picture, what is the reference point here? The reference point is a fixed point. It could be the tree, it could be the house. And this car is in motion if it is changing its position from the reference point. So this car, for example, is at position A, then becomes at position B after 5 minutes. So this car is simply in motion. Speed. Speed is the rate of change of displacement over time. Or simply we can say that how fast the object is moving. Relative motion. It is the change of an object's position or its direction as time passes, relative to another object or a fixed point known as a frame of reference. To make it easier for you, did you ride a train before? While you are riding a train, you look from the window at fixed points like trees, like houses, and you will find them that as if they are moving in the opposite direction of the train. You're moving in this side and the fixed objects outside the train as if they are moving in the opposite direction. This is relative motion. Again, it is the change of an object position or direction as time passes relative to another object or a fixed point known as frame of reference. And what is the relative speed? Look at this example. We have two objects. They are moving in the same direction with two different speeds. So the relative speed is velocity 1 minus velocity 2, or speed 1 minus speed 2. What if they are moving in an opposite direction? So here the relative speed will be equal to the sum or the total of their speed together. Let's discuss this example. This boy is the observer and he's not moving. He's only watching these objects while they are moving. So the relative speed of the objects are their actual speed. This boy will talk about this car that he saw a car moving by 15 meter per second speed, or he saw another boy riding a bike moving with speed 5 meter per second. The relative speed are the actual speeds of the object. Then, here is another observer. This boy, blue boy, on a bike. But in this example, the boy is moving. The observer is moving. Then, we will see the car is moving in the same direction. So, the relative speed here is the actual speed of the car minus the speed of the bike, which is equal to 5 meters per second. What about the observer is moving at this side at the opposite side of the car, and the speed is 5 meters per second. So we can say that the relative speed here is 10 plus 5, which is equal to 15 meters per second, as if the observer is observing this car moving at 15 meters per second. Is this real? No. This is the relative speed. So the relative speed differs. The difference is the observer. If the observer is stationary or not moving, then the actual speed is the relative speed. If the observer is moving, so it depends on the direction of movement and the speed. Now, look at this example. Why is the relative speed equal to 0 when the moving object and the observer are moving with the same speed in the same direction? Let's do it together. Both of these cars are moving in the same direction with the same speed. If we are going to calculate the relative speed, then the relative speed will be the difference between the two speeds, 30 minus 30, which will be equal to 0. We have many types of motion. Transitional motion is one type of this motion. When something is moving from a place to another, this is a transition motion. A start point and an end point. Let's see some examples. Look at this bike. This bike will move relative to a fixed frame of reference and from time to time from an initial position to a final one. This train also have the same type of motion, transitional motion. Transitional motion is the motion where the object position changes relative to a fixed frame of reference from time to time, from the initial position to the final one. What about the periodic motion? It is regularly repeated in equal periods of time, like the vibration, the motion of the pendulum, the circular motion, the movement of moon around Earth, the wave motion, the water waves. Types of waves. Mechanical waves, and they are caused by vibration of the medium particles. They need a medium to transfer through. They do not travel in space, and the speed of waves is relatively low, like sound waves and water waves. Electromagnetic waves. They are composed of electromagnetic field. They spread out in media and space. Wave speed is extremely great, 300 million meters per second. Like light waves, microwaves, radio waves, ultraviolet waves, and infrared waves. Now, can you give reason why do we see lightning before we hear thunder, although they happen at the same time? Let's see together. We all know that lightning and thunder happen at the same time, but why do we see the lightning before hearing the thunder? Yes, because light travels as electromagnetic waves and sound travels as mechanical waves. Electromagnetic wave speed is extremely greater than the mechanical waves. What are the applications for mechanical waves? Medical equipments that use ultrasound waves, stringed musical instruments such as violin, guitar, pneumatic musical instruments such as flute and reed pipes, amplifiers and devices for controlling and distributing sound used in broadcasting studios. Here are some technological applications for electromagnetic infrared waves. Infrared night vision systems used by military forces. Remote sensing instrument in satellites that photograph Earth's surface. Cooking food by infrared rays because they have a heating effect. And remote controls. Technological applications for electromagnetic waves. Ultraviolet rays used to sterilize the sets of surgical operation rooms. X-rays used in imaging bones to detect fractures, and used to examine metal raw in industry to show pores and cracks. X-rays are also used to study mineral crystals. Gamma rays used in detecting and treating some tumors. Visible light used in photographic cameras, television cameras, and data show devices. Now it's time for questions. Fill in the blanks. The motion of the pendulum is, while the motion of a train is. The motion of the pendulum is periodic because it is repeated, and the motion of the train is transitional from an initial point to an end point. Ultraviolet rays are used in sterilization of surgical sets in operation rooms. Electromagnetic waves can travel in matter and space. Sound waves are mechanical waves, while light waves are electromagnetic. Can you give reason why does sound travel in matter only while light can travel in matter and space? Sound travels as mechanical waves which need a medium to propagate, while light travels as electromagnetic waves which can travel in media and space. State one use for gamma rays and one use for infrared rays. Gamma rays are used in detecting and treating some tumors, while infrared rays are used in remote controls to operate electric devices. Thank you. Dear students, thank you for watching. See you later in other science episodes.